anything which is revolving, right? Revolving around. So let's say this is a nucleus, and then it's going around. Electron is going around the nucleus, right? So whenever something is going around the circle, right? So whenever something is going around the circle, it is having something called centripetal force, right? Without the centripetal force, it cannot change its direction, right? So you see, if something is going in straight line, right, it can be having a constant velocity and acceleration can be 0. But whenever something is going around a circle, you cannot have acceleration 0. So it is accelerating towards the center all the time, and that is what you have studied as centripetal force or centripetal acceleration, right? So when the electron is spinning around this thing, so what people argued was, so since it is accelerating, the accelerating electrons should lose energy, so it will eventually fall into the nucleus, making atom unstable. Okay, so this is the most important limitation. So what they said was, if I had a nucleus like this, it's not going to go around like this. The electron cannot keep going around like this. Instead, it's going to just take a spiral path and then it will fall into the nucleus, because it's continuously emitting electromagnetic waves. Why electromagnetic waves? How electromagnetic waves are produced? Accelerating charge. Electron is a charge. So whenever something is accelerated, charge is accelerated, it will be giving you electromagnetic waves. Okay. So if I take a spring and if I move it like this, I'll be producing waves. If I take a charge and if I do it like this, I'll be producing electromagnetic waves. Okay. So this is also accelerating electron. Whenever I told you, whenever something is going around a circle, it is accelerating. Are you following what I'm saying? So that means it should lose energy, giving out electromagnetic waves, and eventually it will fall into the nucleus. So this is one of the limitation of Rutherford. So this is the first one. Second one, anybody remember? What is the second limitation? It didn't explain? Line spectra, right? What is line spectra? So different atoms, right? Say for example, I think I already explained you. I don't know if I have that book to show you. So there is something called line spectrum. Okay. So when you have some hydrogen or helium or some gases, so it can be helium, for example, or it can be cadmium or mercury. So when you use some electrical energy to excite these atoms, using electrical energy, these atoms can be excited, taken to a higher energy level, right? So if I take something like this, I am exciting it. So I am taking it to a higher energy level, right? So compared to this, this is in a higher energy level. So when they fall back, right? So when they fall back to this original, so it doesn't stay there. So if I take it to the higher level, does it stay there? The moment I leave it, it's going to fall down, right? So similarly, when you give some energy, right? So the concept here is the electrons are excited to a higher energy level, and when they fall back, it will be giving out the difference in energy as h nu. Okay, so this is what is called line spectrum. So meaning, so when you see the diffraction grating, right, you will see a WebGR spectrum, right? WebGR, the visible light spectrum. So instead of seeing the entire WebGR, in some gases, what you will see is, you will be seeing only specific lines. You will not see the in-between colors. You will see some You see, this is your Vibgya, right? Continuous spectrum. So from violet to red, you have everything, right? So when you say colors, it's all different wavelengths. Different wavelengths means different frequencies, right? So you have different frequencies here. But this one is something like mercury vapors. So from the mercury vapors, when you take mercury gas, gaseous atoms, and then when you excite it using electrical energy, right? So what you will see is you will be seeing some light coming out like this. So what you are seeing here is you are seeing some little bit of a violet here and then green and then yellow. That's all. So you don't see any other frequencies. Are you following what I am saying? And then if you use helium gas, so you are seeing some other lines. And when you use cadmium vapors, you are seeing some other lines. So these people were confused for a long time. They didn't understand why this is happening, right? Different gases are emitting different colors or different frequencies, right? Instead of emitting the entire spectrum, it was emitting only certain frequencies, right? So this is what is called line spectra or line spectrum. Okay. So this atomic model, Rutherford's model, it was not able to explain why we are getting only specific this thing. Actually, this comes a little bit later, so maybe I should not talk about this right now. So one more limitation here is, so the Rutherford model, it cannot explain line spectra from gaseous atoms. Okay, so for a long time, scientists were confused, why we are getting this kind of line spectra and how to explain that. Okay, so this is another limitation of Rutherford's model. Because if this happened, suppose if the electrons are going to, lose its energy and fall into a, helical path, right? What will happen is, or coil into this, right? It's going through different energy levels. When it is going through different energy levels, you should be seeing different frequencies coming out, right? Instead, you are seeing only specific line frequencies. You following what I am saying? So that means, as if electron was to lose energy and fall into nucleus, it will be emitting different frequencies. Why? Because if it is different energies, it will be different frequencies. But instead of continuous spectrum, only line spectrum is observed. So this it cannot explain. So if they ask you what are the limitations of Rutherford's model, you are supposed to write these two things. Okay. So only if you understand what is line spectra, you can at least attempt to write it. If you don't even know what is line spectra, you cannot explain that. Okay.